All right, so let's finish this review up. This is 313. We're looking at absorbance, and specifically this section is referring to the Beer-Lambert equation. So if we start off with the Beer-Lambert equation here, what we get here with this equation is the following. So let me just go ahead and write this over here. That is equal to the absorbance is equal to E, which is the molar absorptivity. We also have B, which is the path length, and then C, which is the concentration of the solution. And so the units associated with these here are going to be moles per liter. The path length is actually centimeters, but the way the units are represented are going to be liters over mole per centimeter. And what's going to happen here is when you look at these, the liters here cancels with that, and moles cancels with that. And so you end up with centimeters, just to clarify there. And then the last one here, the absorptivity, this is a unitless value, so there's no units here. That's just the value there. And so the absorption here that we're interested here, this value here is the key stroke, I guess the key thing that we're looking for here. We usually represent that as ABS. And it's usually represented as a percentage. And the way this works, as you recall from class, that you have a sample. We've already created a sample. So we've got the sample here. We run the experiment and it's got a certain concentration to it. So what we're going to do is just represent that there. So we take this concentration. We're going to take a sampling of this concentration. We're going to put it inside a cuvette. And the cuvette is literally just a little, I guess, a little squared or rectangular piece of equipment. And we enter that liquid in there. We add it in there, and the liquid's going to be inside. And the ridges, there's ridges outside on the cuvette here. There's got some ridges here, that extensions that come inside. And light is really going to travel here between this. So when we put this in, we want the light to actually show up or arrange the cuvette in such a way that this portion right here is aligned in the machine. So the machine is, let me just draw the skeleton part here. This section here, if I'm going to go ahead and make a copy, so let's just take one of these copies here. This copy here will essentially bring it in, and let's do it this way. Let me go ahead and kind of make this a little bit smaller and then bring this in. So we bring it into the sensor, and it'll be in here, a chamber that we can put it into. And there's a light source here that essentially is going to emit light. And so that light, when we go through, now keep in mind that the way I've positioned the cuvette here makes it seem like it's going to be up against the ridge and it's not going to get through. But just keep in mind that when we go through, the light's actually going through the little tunnel here all the way across. And so that's really what I should be showing you there. So the light's going to make it through, and so when the light goes through, intentionally what's going to happen here, there's not going to be any break in the distribution of the light. It'll go all the way across, and over here on the other side, you're going to have a sensor. And it's this sensor here that's going to report out. It's going to report an absorbance number. And the absorbance number can be from 0.000 all the way down to 1. And so at the lower end of things here, this 0 means there is no obstruction. There's no obstruction there, but at the 1%, which is essentially 100%, this is going to be a full obstruction. And so that's a problem for us. So the idea here with an absorbance is that if the concentration of the solution that we use to put into the cuvette is actually high, that actually is going to mean that we expect there to be high absorbance. Now, we don't know that. We know at a certain thing, but typically when we do this, we're running the experiment ourselves trying to figure out what the concentration might be. And so here, the relationship between this is, if the concentration of the solution is high, what we expect here to be is that we expect the absorbance value to be high. And on the flip side of that, if the concentration of the solution is low, then we expect that the absorbance value here will also be low, because they're proportional to it. And so you should be prepared to answer questions like that. You should also be prepared to answer any problems that may arise as a result of the reductions in the absorbance. So what are some things that could happen to this region here? in terms of the cuvette. And remember from our discussions in class, some of those interruptions that could prevent the light from going through this particular path here all the way across is that things that could bring the absorbance down would be that maybe there's oil, there's smudges, there's fingerprints, maybe the concentration is high, maybe there's all kinds of things that can happen to obstruct it, maybe some fuzzies on the surface of the cuvette, you didn't clean it off. All of these things here would essentially increase the blocking of light going through the cuvette, and that would essentially cause there to be an obstruction. Now, on the other side, what's one thing that can actually bring down the absorbance? And that would be, for example, on the other side of things, the thing that could happen there is that maybe there was a little bit of extra water to begin with in the cuvette. And so the concentration, because the volume is greater now, the concentration should fall. And that should essentially allow you to make that kind of conclusion based on that. Now, the main thing that here in this particular section that a lot of us were trying to look at is, can we take this information and apply it in the most common application that you'll see on an exam or a question would be if we were to take a data table of various solution concentrations, certain absorbances, and once you have the data plotted, can you determine what happened? So what are some common errors that might have occurred there? So let me make some room here for us, and we'll bring some of this information across, and let's explain what that means. So a common thing would be that if you had some data from absorbance here, and then perhaps on absorbance we had concentration, so the letter C. And so what you could find is that we gave you some values here, and so whatever these numbers are here for the absorbance here and the concentration, the idea is that if we're able to graph this, we're going to find that there's going to be a relationship. Now, we expect there to be a linear relationship between the absorbance and the concentration. And so most of the points that you're going to see should line up on the graph, somewhere along the graph. And I'll just draw these here. Maybe use blue so you can see them a little bit better. And so they should line up on the graph. Now, the question then becomes, what if there's a point that comes below the graph or, say, a point above the graph? And so, in particular, we're talking about this one here, and we're talking about that one there. So let's label these point A, and let's label that one point B. So the question that you might get, or a variation of the question, would be, which of the following explanations would explain why A is below the graph? And obviously that would correspond to a certain value. So let's say that absorbance was over here going that way, and then concentration here would be going that way, increasing from 0. And so the idea is that if you can go here and extrapolate this value all the way down and to the line and coming it back, you should be able to see that there's something here that's wrong. So because the concentration is a little bit lower now, we would expect the absorbance to be at a certain level. But because it's at a certain point below that line, we don't quite get the absorbance that it should be in relation to that concentration. So that's a problem for us. And in this particular case, because it's below the line, we know that the concentration is a little bit lower. And so the question that you, or the conclusion you should reach is, the reason that A is below the line is because essentially what you might have had there would have been a reduction in concentration. So here A essentially would have been here seen because maybe there was a reduction in the value C for the concentration. On the flip side, point B here, the reason we would see B above the line would be that maybe there was an increase in the value C for the concentration. Okay, and so being able to kind of work that out by graphing, interpreting the data, that would probably be a first step for you. But generally, this section is going to be dealing with the absorbance, how you prepared it, how you ran the test, and all of you had an opportunity to do that in class. So hopefully that was helpful for you in getting this last section prepared. Go ahead and finish up your studying, review all the notes that you had in this section, this second section for the Unit 3, Part B, and then do your preparations in advance of Monday and Tuesday, and we'll see you in class.